This problem this time has a point pxy, so little p moves around, it's moving anywhere it can, but the rule it's got to follow is that its distance from the y-axis is equal to its distance from a particular point, 4, 2. So if that's the case, we have a look at our diagram here. 4, 2 is our point there. There's our y-axis there. So the distance basically has got to be the same going from the point 4, 2 to the y-axis. So anywhere along here has got to be the same distance there. Now remember, we've got to go that direct distance there. It can't be anywhere. It's got to be a direct distance from the point to the y-axis, because that's got to be the shortest distance. What we're going to do is let any point on the y-axis be a y0. So if this is the point xy up here, okay, if that's x and y, this is going to be in a direct line. Okay, now I know that because it's on the y-axis, the x value is 0, and that's going to give me some point y. And because it's y, because it's in line with that point there. So x, y is there, so that's why it's the same y coordinate there. We've got the point 4, 2. So the distance on this one must be exactly the same distance on that one. So that's why we say PA and PB have got to be equal. So again, apply the distance formula. Again, what we're using is the distance formula. And then start manipulating. Our square roots cancel out because we can square both sides. We can start to clean up this side. X minus 0 all squared gives us the x squared. Y minus y nicely gives us 0. So it just gives us left hand side as x squared. Expand that one. X squared minus 8x plus 16. And the y squared there. Y squared minus 4x plus 4. X squareds cancel. And then if I add 8x on this side, we can see that's going to be a parabola. It's y squared this time, which means it's a parabola on its side, but it's still a parabola. Okay, so we found the equation of the locus of P. There's our equation. And what does it signify? It's a parabola, even though it's on its side. Its concave is open to the right. But it's still a parabola. The last question here, P is the point 0, 2, Q is the point R minus 2. This time we've called the point R that's going to move. So we're going to move this. So at all times, PRQ is a right angle. Again, it's going to see that they're going to meet at a perpendicular. So show the equation of locus is a circle. That's what we should show. And then we need to manipulate to get the center and the length of the center of the circle and length of the radius. So our gradient is going to multiply to give us minus 1 because 0, 2 and R is going to be perpendicular to Q, which is 4 minus 2 and R. So the gradients of the lines are going to multiply to give us minus 1. So we applied the gradient formula, so distance formula or gradient formula. That's all we've used in these questions. And then we start to expand it out. So that gives us a difference of 2 squares, which is y squared minus 4. X multiplies by x minus 4, gives us the expression there. Multiply through by our denominator to clean it up. And then notice that's why it's negatives on this side and the positive 4x. Collect it all over the same side. And we start to see that, well, yeah, it's starting to become a circle because it's x squared plus a y squared. We've got other terms. So we start to complete the square again because I need to get a perfect square involving this part, which would be x minus 2 all squared. Take 4, divide it by 2 and square it, gives us 4. Y squared is already a perfect square, so that's not a problem. We add 4 on both sides, must add it on both sides. That comes down to a perfect square. That gives us 8. So we're in the form of a locus being the circle. Our center is 2, 0, because that was y minus 0 is all squared there. And the radius is square root of 8. If you want to write that as 2 root 2, that's okay too. Even a decimal, it's not really going to matter. But we're seeing that it is a circle, which is what we wanted, and we're getting the center and the radius.